What if AI learns a bad habit it can't unlearn? This paper reveals how that's happening now. Let's get into it. Let's start with a featured paper, SkillJack, Persistent Skill Backdoors in Self-Evolving Agents, by Zonghao Ng and Jinghua from Tencent, UK Lab. Here's a full breakdown.
Let's start on the left with the attacker injection, where an attacker creates a poison experience. This malicious trajectory is then injected into the agent's experience corpus alongside legitimate ones. Feeding into the next stage, the system's own transform process is hijacked to process this poison data. The LLM extractor is tricked into converting the malicious experience into a structured, but harmful, skill. Next, this malicious structured skill is passed to the persist pipeline. Here, it's implanted directly into the skill library, becoming a durable and seemingly legitimate skill the agent can use. Finally, the attack achieves a critical property called persistence isolation. This means the malicious skill is now decoupled from its source and remains in the skill library, even if the original poison experience is found and deleted. SkillX with the frame payload achieves substantially higher LLM evasion compared to its own direct baseline and other systems like A2S SDK and A2S DOC. Specifically, SkillX framed demonstrates an LLM evasion rate of 88.6%, outperforming the next best result by a significant margin.
Up next, our second paper out of 3, Vulnerabilities, Secrets, and Misconfiguration in the Highest Exposure Docker Hub Images by Christian Kapelinski and Diego Kreutz from AI Horizon Labs, Federal University of Pampa, Unipampa. Let's break down its key contributions.
Our pipeline begins by querying the Docker Hub API using a Go-based crawler. This crawler systematically discovers repositories through prefix search, ultimately identifying over 12.7 million of them, which are then stored in MongoDB. Feeding into our second stage, the builder, we pull the discovered images to reconstruct their structure. This process builds a layer forest representing the image dependencies, which is then loaded into a Neo4j graph database. Within this builder step, we also calculate a novel metric called the exposure score. As noted by E of I here, this score measures an image's impact by considering not just its own pulls, but also those of all images built upon it. Next, using the exposure score to prioritize, we move to the final multi-scanner scan stage. Here, each high-exposure image is analyzed by a suite of 6 different scanners, including tools like SYFT, Gripe, and Trivy to get a comprehensive security profile. Chimango scan, this work, is the only method presented that comprehensively covers vulnerabilities, misconfigurations, secrets, and cross-scanner analysis. It also employs 6 scanners, matching the highest number used by prior works, and analyzes a substantial dataset of 52,895 images.
Up next, our third paper out of 3, Permission Denied, Policy-Graded Evaluation of Coding Agents in Hardened Environments by Dotan Davidovich and or Hilch from Accomplish AI. Let's break down its key contributions.
To start, we look at the mean cost multiplier for agents compared to a control environment, which is represented by the 1x baseline on the horizontal axis. This shows us how much more effort agents need when we introduce security policies. Feeding into this, we introduce different security policies, such as the NIST-derived high policy shown by the green diamonds. These policies harden the environment to simulate real-world restrictions on the agents. Next, we analyzed why these costs increase, though this chart doesn't show the full breakdown. We found that agents either timed out or produced wrong answers when their actions were blocked by the policies. To ensure a fair test, we separated tasks into those affected by the policies and those that remained unaffected. For these unaffected tasks, the cost multiplier stays low, confirming they are still solvable even with the new constraints. Finally, all of this work is encapsulated in our open-source release, Boundary Bench. This plugin allows anyone to apply these policy constraints to evaluate their own coding agents. The evaluation demonstrates that coding agents achieve substantially higher success rates under the control policy compared to the more restrictive non-root and NIST-derived high policies. While the control policy allows for success rates exceeding 80%, the top-performing models under the NIST-derived high policy reach approximately 75% success.
Those were the top papers. Now, let's zoom out. ArXiv received 792 new computer science papers across 53 subfields today. Here are the trending areas shaping the field. Zooming out, The day's research clustered into 5 big themes: building smarter AI agents, evaluating and enhancing LLMs, practical AI system concerns, AI for scientific discovery, foundational algorithms, and systems. The full paper list is in the pinned comment below. That's all for today's ArXiv Computer Science Daily. If you found this helpful, please like, leave a comment, and subscribe for daily paper summaries. See you tomorrow. Thank you to ArXiv for use of its open access interoperability.